Okay, before going further to today's topic, to the multiple inheritance, do you have any kinds of question about the definitions in this area? Because last time, as I say, you can actually use next word prediction type of search queries. You can just write a noun or a gene is a, and then you can actually take the most relevant sections of different pages, and then you can actually see that how Google relates certain types of words or certain types of concepts to each other, and you can take the most popular ones and the most prominent ones to create a more compressed and dense definition in your way. There is one more thing actually. The 2 days ago, Google actually posted a new blog post, and their new blog post is actually only about the quotation mark in the queries. Whenever you take a kinds of term between the quotation marks, they always check the web pages that actually have the quotation mark. And in the blog post from 2 days ago, they were actually explaining that if the quotation mark term appears in titles or the URLs, they don't care about it. They also explain that if the quotation mark term appears in main content, they choose the main content over the boilerplate content. At the same time, the quotation mark term might not appear in the visible section of the document or the critical section of the document, even if it is cloaked, even if it is hidden, even if it is just in the structured data, still they assume that, or they tell that they will actually consider the term relevant to that specific index request. So you can also use this understanding to expand what we have said in the past lectures, because basically when you search for any kinds of term by saying is a, they will actually try to check the most prominent or the closest concepts or the words to that specific noun or to that specific term. In this case, they will actually try to check, let me just write here a couple of things, maybe they can help you. The word proximity, the word combinations, then the word vectors actually, and they can also check the word co-occurrence matrices. So to even further or expand the explanations here, if you check the term let me just write occurrence matrix. This is actually a concept from NLP, and it actually works together with the vectorization, at least for the most of the time. And based on the co-occurrence matrix, this can be used, by the way, for not just for NLP, it can also be used for e-commerce analytics or other types of things. But most of the time it is about distributional semantics. And most of the time with Python, even you can actually create some co-occurrence matrices. So basically here we have words in the column, in the rows, and we check which one appears together with which one. There, I will give you one more concept here so that you can actually use some of these things later as well. Another concept is called actually word of interest. Here we have a couple of words. It says bird, sitting, wall, cat, fence. And we have some other words here. The thing is, the word of interest is the actual word that has most ones against the zeros. If a specific word, let's say the bird, if it actually has more ones, it means that actually it is more prominent than the others. In this case, it can be actually this one, which is usually the predicate in this case. And the concept of word of interest, if I search it, word of interest, sometimes you can see the same term in NLP works as central words or context words at the same time. But let me just search it with the NLP or some other helper terms. Maybe I can find it. But basically, the word interest here doesn't reflect the meaning that I search to the Google directly. Maybe this time I can use these quotation marks if I can find some things. Yeah, there is a couple of things here. Let's check it together. Word of interest. So in this example too, based on proximities, again we have an example actually with the cat, whiskers, computer, laptop. And based on the co-occurrence matrices here also we try to find the most interesting word, the word that changes entire context. And to be able to write better definitions, whenever you write a paragraph here like this, maybe you won't have enough conditions to create actually these co-occurrence matrices or to calculation of the for the calculation of the word of interest, but from your brain or from your mind, as a reflex, you can at the same time actually think these type of things. As you remember in the last lectures, I also told you that try to use more contextual terms so that you can consolidate the contextual relevance further by actually using more dense co-occurrence matrices. Whenever you have actually more better contextual words like here, howl, dog, tree, wood, leash, sharp. So basically when you have the word barking or bark, these are the closest contexts for that. And if you use a couple of these things together, it means that actually your context is a little different from the others. Every combination that you see here, from tree to wood, or from tree to dog, or from howl to shrub, all the contextual possibilities will change. And whenever they change, all the possible query relevances also will change. Okay, since we didn't see each other for the last 3 days, I just wanted to explain a couple of things further. And let me check. Okay, it takes my voice as well. Happy for that. So let's dive into the multiple inheritance. The concept of inheritance, it also exists in everywhere actually. It exists even in CSS or other things. Basically, in programming languages, whenever you create a class of object, every sub object of that class actually has the same attributes, even if the attribute doesn't have a value, even if the attribute is null. So maybe giving an example from the programming language might not be perfect, but it is actually called, let's say, object-oriented programming. Because in object-oriented programming, we always create an object, then when we give actually certain types of attributes to it. And when it comes to the multiple inheritance, the problem here is that we have a certain entity, a certain named entity, and it has contradicting attributes and contradicting attribute values. And when we have contradicting information on the web, the search engine actually can't serve both of them at the same time. And the search engine will need to choose a certain amount of fact or certain confidence score to be able to serve that declaration or proposition. And if we say that, I actually have an example here. Let me just read. This example, by the way, it is also related to the product review update. So let's read my explanation here. Here I say, these inherited values can be conflicting, especially in the content marketing area. It might be more problematic to say X is best while Y is best too. Imagine that in one of your web pages, you say that NordVPN is the best, and then in another web page, that affiliate marketer says also Kaspersky or something else is also best too. So two things can't be best for the same area at the same time. So it means that you are actually giving contradicting and random sentences. And it is also against the groundedness that I have shown before from the language model of Google, from the Lambda. In this case, a context has two different best ones, but which one is the perfect? Both or one of them? Or is one of them is outdated declaration? Let's say you have said that X is best, but let's say this is from a web page from the last year, and this is the latest sentence that actually comes from you. It means that actually your website has content decay, and it means that actually we can't also trust your last year document that much, or other documents from the last year as well. If you check the product review update plus also the quality rater guides of Google, you will actually see this type of page quality assessments, even if the web page is really relevant since it is old. And there are lots of numeric values in the queries or documents, they will actually outdate or filter out that specific document. So in this case, let's say a person might be a footballer and a basketball player at the same time. When we say he or she made a score, the context is ambiguous because you can actually make a score in a football game and also in basketball game as well. And the specific named entity here, the person is a footballer and basketballer also at the same time, because we do not know which game he or she plays here. Or there is another example here, and we will be able to explain the concept of multiple inheritance even a little further. When we say Nixon is a pacifist and a Republican, it is conflicting because we know that a Republican is not a pacifist. So which one is better or which one is correct? So these concepts here, until now, I actually show you most of the time the distributional semantics. Now actually we dive in natural language inferring or inference, which is one of the most important things lately to understand the efficiency of a language model. Because most of the time, the information that we can actually extract from certain web pages, they are actually not told in an explicit way. Most of the time, it is inferred. And natural language inference is actually a task to understand the common reasoning and to understand or augment the information even further. So here I actually need to show you another language model, which is Realm. And I will tell you one name, and you will need to remember that name for the future researches as well. Even if let me check, maybe his name is here, Jacob, no. So I will write the name here, Jacob Devlin. So the Jacob Devlin, actually, he is a computer scientist, and actually he directly actually works at Google, and Google actually he is from the Google Brain team, and he actually worked lately into the PaLM, which is Pathway Language Model, which is something different, and we can talk about it later too. The PaLM basically is basically a language model. It is actually announced in the Google I/O from this year, but SEO industry didn't care. I don't know why. And the PaLM, imagine that you have just a single language model for any kinds of NLP task. So basically, they try to actually make things more standard or easier for themselves. And you can actually see the name Jacob Devlin also here too. So why the Jacob Devlin is important? Because he also worked in the realm. Now I will show you one example for understanding the natural language inference. If you write your content by saying, we paid 20 at the Buckingham Palace gift shop, and if you don't give the currency here, it means that actually we will need a neural net retriever. And then we will actually try to check the semantic dependency tree. Semantic dependency tree means that a certain entity actually has certain attributes because of its type. Let's say this is an entity and the name is, let's say, X. And let's say this is the type of that entity, and let's make X and let's say animal. So if X is an animal, it means that actually this specific animal probably or most probably at the same time, let's say, has lungs, or let's say here the lungs, and we can actually write the relation type to this area, let's say has. So in this case, we actually, if we didn't know that X is from animal world, we wouldn't know that it actually has lungs. So in this case, here too, this is what actually semantic dependency tree is. And the example here also shows that. When you say Buckingham Palace gift shop, Buckingham Palace is located in British monarchy and pound is the official currency of the British monarchy. So it means that the pound is the first and most confident candidate that we can use just after the 20. And this language model is actually for understanding the natural language that we use in our daily life, the routine language. And if they're able to understand these semantic dependency trees by actually filling the missing areas in our ambiguous language, they will be able to understand us also better too. So this is what natural language inference. And when we come to this area, again, back to the Nixon. So I will try to draw another example here. Sorry, let me just make this thing bigger a little. So let's say this is Nixon. Just here it stays. And let's say this is Nixon's political party. And let's say this is the Nixon's political opinions. So I will put the Nixon here. And here I will tell the political opinions of Nixon, and this is the political party of the Nixon. And then here I will put one more thing, and these are the political opinions of the party. Let me just put it here, put these connections here too. So like this, and let me write the relation types here as well. Let's say has can be here, and is, let's say, member of, and let's say again we have a has relation here, and let's say party opinions. So I will put one member under these things, and here under this one we will actually have an example, which is the pacifist or political pacifist. And here, let's say, let me just put it here, and the political party opinion here, it is actually, let's say, aggressive, or let's say aggressive in this case, which is the a little antonym of the pacifist. So when you have this type of a simple knowledge graph and plus information graph, we have a contradicting connection. So we tell that Nixon actually has some political opinions. Let me just use my sign language with the arrows. So here basically we have the Nixon, which is one of the older United States presidents. And here we tell that Nixon has actually political opinions, and these political opinions entail also being pacifist. And when we look at this area, Nixon is also a member of political party. Political party also has some opinions, and including being aggressive in foreign relations. So in other words, between these two, if you look at this area again, between these two are antonyms and conflicting decisions. So in this case, which one do you think that the search engine will choose? Which declaration is more accurate and factual? Nixon is a pacifist, or Nixon is actually, let's say, not pacifist or aggressive for foreign policies? Which one?
Probably depends on the weights of those other entities, and the more relationship he has, like let's say in one side, this side is stronger, therefore the argument is more true.
Which one in this case, pacifist or aggressive?
In this case, it's equal for me.
Equal, okay. And others, what do you think? Which declaration will be more accurate or correct? We have multiple inheritance here. Being pacifist and aggressive are or is inherited by Nixon at the same time. And it is not possible to be both of them at the same time. And last time, as you remember, we also talked about fuzzy logic. We told that there is no absolute truth or absolute wrong, but still one of them is more accurate or more factual. I can have a second guess. Povilas or others? Since I can see, since I use my laptop, I can see who is there. Okay, let me just check your names. I want to hear your guesses. Edwinas, any guess from you? No?
No idea, actually.
And Montas, do you think anything here?
I think Nixon is associated more strongly with its party, so probably its party
Okay.
ideas are
Okay.
stronger in the sense.
We have two different Ugne here, or Ugnes. Sorry if I am butchering your names. Do you have any guesses? Both of the Ugnes?
I kind of do. There is a theory even for this, for Nixon Diamond, at least it's so called. There is more context that Nixon is more aggressive, so at least in the search results, Google already knows that Nixon is more Republican because he's a Quaker as well, but there is not as much proof that he did anything pacifist. So in this case, just context works and more search results.
Okay, so let me explain the multiple inheritance and also one more concept here, which is called actually inheritance path. So if you have conflicting inheritance for a specific entity at the same time, the thing that you should actually do is check the inheritance. Let me just write properly, inheritance path. And this means that you will actually need to compare the distance from being a pacifist to the Nixon and being an aggressive, or let's say not pacifist, to the Nixon. So if you look at this area, let me put my red arrows again to explain it further. So if I check from pacifist to the Nixon, here actually I have only one edge with two different, one connection, and this is the second connection. So we can tell that the distance here is actually only 2. But if I look at this area, this is 1, this is second, and this is the third. And in this case, the inheritance path from being aggressive to the Nixon, it is actually longer. It means that this attribute is less relevant to the Nixon. Another thing here is that being aggressive is actually an attribute of the Republican Party rather than individual Nixon. But being a pacifist is a direct attribute directly to the Nixon. So in information graphs, we actually have direct attributes and also indirect attributes. And based on the inheritance, sometimes you can also inherit being an aggressive, let's say for certain acts, certain days, certain years, or certain conditions, or certain topics. But most of the time, saying that Nixon is a pacifist is actually more accurate because it is a direct attribute, it is directly related to the Nixon. But this one is directly related to the political party. You can also reverse this. For instance, you can tell that Republican Party is aggressive. It might be true, which is actually the true, but at the same time, Nixon is member of this Republican Party, and Nixon is not aggressive. Nixon is a pacifist. So in this case, Nixon actually shouldn't be member of the Republican Party according to the inheritance rules, but still he is. In this case, we still will actually need to override some of the facts in the information graph, and in this case, we will need to tell that some members of the Republican Party doesn't agree or don't agree, or they don't carry all of the attributes of the Republican Party. And once we realize this, we will also need to go deeper. For instance, when Nixon agrees with his own party and when he doesn't. If you write your own document, you will need to differentiate all these things from each other. And you should remember the distance between attributes plus inheritance path. If the inheritance path is long, it means that actually the relevance is lower. And to be able to create an inheritance path, you will need to imagine these connections in the form of a graph in your mind while writing, so that you can actually give more attributes, more triples, higher accuracy to the search engine while writing for the NordVPN as well. So let me continue a little further. Here too I actually explained Nixon is an entity, Republican is an attribute, and Republican Party and the foreign policy, it is another attribute, but this attribute actually belongs to the Republican Party directly. And you can also count the arrows here, which is actually higher from Nixon to the foreign policy understanding of the Republican Party. There is a longer path. So we already actually talk about relevance of inheritance, but let's read it. Relevance of inheritance means that which inherited attribute is more important than another. And to understand which attribute and its value are more valuable than another, the entity should be analyzed with the dependency tree and inheritance path. So I will try to explain it a little in this way. So we said that Nixon is actually an older United States president. Let me just put another text here. Sorry for my bad paint skills. I will tell the president here, let's say president of the US. And in fact, actually it should be like this. He is a president, and being, or let's say this president actually belonged to another thing here, which is actually the US. It should be like this. And once we have these things, we will try to understand which attribute is more important here, which fact is more important. Being a president, being a member of the Republican Party, or having political opinions. And same Nixon, at the same time, he can be a husband to a person, I don't know who, let's say another person, I don't know the spouse name here, but let's say X here, and we can tell the spouse. And now this topic is a little about, let me just write, phrase and entity association from queries. There are more concepts here that I can write. For instance, query aspects, or let's say query identification, and etc. Because according to the query, the context will start to change, as I show in the occurrence matrices, or as I show in the word of interest situation. And according to the query, the most important attribute will start to change. If the query includes the name of the spouse, then this section, this area will actually be highlighted, and all of the related other words around the spouse, or all of the possible attributes, also will start to be more important. But sometimes we also don't have these type of entity association phrases. If someone asks the question like this, who is, let's say, Nixon, or who was the Nixon? Would you tell that Nixon was husband of X, or would you tell Nixon was, let's say, 46th president of the US? So which one of these sentences actually give a better definition here? Sorry for removing it. Let me just write it again. Who is Nixon? And we have two different definitions here. Definition 1 says husband. Definition 2 says president. And in this case, the search engine, which one do you think will be more satisfying for most of the clicks? What do you think? You can answer. We can be quicker.
I'm not sure how to count it, but somehow significance should be in the play. So the guess would be president.
Okay, so you are right, but what is the measurement for that? Because when you say who is Nixon, we don't have any kinds of associated phrase, because we don't have an attribute there. We don't have the word like marriage, acts, bills, wars, relations, international politics, or any kinds of helpful word doesn't appear there. And if you are a search engine, yes, the president is more important from the Nixon's point of view, not being a member of political party, not being member of a golf club, not being exposed to X. But why do you think that the president will be chosen, and what is the methodology of the search engine there? We can have guesses.
Just counting all the semantic, relations, words, phrases, and since most of them are more related to the president than the husband, and that's probably how it's done.
It's true. The best possible way in entity-oriented search to be able to do this thing is actually counting the connections. If you have more connections for a specific attribute, it means that actually there is more intensity there, there is more information there, and most of the time queries will be correlated with these numeric values. So since my paint skills are bad, and since I am using my laptop with a small screen, I won't be able to create that much represented relations here. But when we have Nixon here, let's say we wanted to create this information graph completely. And in this case, which side of this information graph do you think that would have more connections or more intensity? When you look at the president section, there will be other presidents will be connected to Nixon, and all of them will be compared to Nixon. And when we look at the Nixon, we will have some war decisions, some acts, and also some scandals, some quotes, and also some critiques about him. So all of these arrows actually represent different types of relations to the political side of this specific entity. But when we look at this section, the husband side of these things, we won't see that much personal life related news or articles or search queries or any kinds of possible relations that much. We can have children's around here, just two. Then we won't have, of course, the wars or other newsworthy things. And maybe children, maybe some other scandals, maybe a divorce, and maybe a couple of other things. And whatever I draw here, again, these things actually will be connected to this political area again, because people will start to critique, people will start to actually connect these things to the president identity again. And another thing here is, once we actually calculate the numbers of documents on the web that focuses on two different sides of these things, most of the time we will find that there are millions of queries, millions of documents that focuses on all these political things, but maybe only 5 or 6% of the documents will focus on the personal relation of the Nixon. So in this case, since one of the sections are searched more, and since there are way much more relations in this area, it means that actually you will need to focus on the president section. But it doesn't end there too, because this was the easy section. But let's say also what side of the president? Economical side or war related things, or I don't know what presidents do in their daily life that much, but I believe they do a lot of things, for maybe from space to tourism, from safety crime rate to the water quality to the air quality, to do, I don't know, to do LGBT rights or anything that we can actually put there. And in this case, you will need to use actually the same thing. You will again, actually this time you will make a zoom like this. Then you will need to count other micro connections, and whichever section is more popular, it means that actually it is more important. So now I will try to explain you one another thing. What if we have contradicting numbers? Let's say, let me just draw two different representative chambers here. Let's say here we have this, and then we have this. Let's say these are queries, this area are the queries, and this area are the documents, and we will need to match these queries to these documents around, let's say, this specific entity, and this entity is the Nixon. So we will try to take all the attributes in the queries, we will connect them to the Nixon, then we will connect these things back to the documents. But there is a problem here. Let's say the queries focus on this area, but documents focus on this area. So the search engine actually wants to rank a different attribute focused on web documents, but they don't appear that much, or they don't have specific type of page rank or other things. These type of things actually can happen, especially if you have a newsworthy trend, because suddenly the spouse might be dead, the spouse might be assassinated or something like this. And even if they're able to rank newsworthy sites or news websites, after 6 months or after 2 years, we will actually need to rank some other things when we ask for who is Nixon. Even if this section is way much more bigger or way much more dense, still you will actually need to balance the relevance between this pose area and this president area. And in your definition, at somewhere, maybe in the second sentence, maybe at the third sentence, as I did in some of these definitions, let's say for the eagles, if you remember that I was telling that eagles are member of this bird family, then I was also telling that eagles are icons. So at some point when you order these things like this, for any kinds of newsworthy situation, trending search queries, or sudden changes in the real world data, you will be able to actually rank, and you will still be able to stay relevant for these situations as well. So if we continue, I have actually explained the relevance section a little. Then we actually explained the longest path of inheritance. The longest path of inheritance means that the inheritance happened from the longest possible path, and it has a weak connection because of it. Usually these inherited paths cover more people and more common things rather than unique things. If I explain that last part, when you say actually being member of let's say, being member of Republican Party. It's not something unique. Most probably they have like, I don't know, 50,000 other members. So in this case, being aggressive via Republican Party is not that specific. It's not that unique to the Nixon. But when you look at this area, political opinions of Nixon is only for the Nixon. In this case, it is a unique attribute actually. And it is actually just for the Nixon. Since it is unique, since it is more narrow, we actually again choose it. And whenever the path of inheritance is longer, you will have more connections. Whenever you have more connections, every connection actually will share the total relevance or total prominence, and all of them will actually be less relevant to that specific entity. And here too, if you look at the shortest path of inheritance means that the inheritance value is unique and more relevant to the specific entity, as I say. The inheritance path closeness represents the relevance of the inheritance value. And if you look at this area, when you tell Nixon is a person, pacifism is a policy for foreign affairs, which is a definition. We define both of them by giving the types. This is a policy, this is a person, and it means that they can be united in the information graph. Then we also tell politician, which is a subtype of the person. Then pacifist is a term for federal politicians. So we tell that, for instance, let's say you have another politician, but that politician might not be pacifist, even if that politician is actually a politician, because that person has to be a federal politician rather than just county level, state level. The person will need to be at the federal level. So being a pacifist can be an attribute only for federal politicians. Nixon is a federal politician because he is president. And this is what actually we call as natural language inference. Nixon has a political party. Nixon is a member of Republican Party. Nixon's party is not pacifist. So in this case, when you create actually these things, Nixon, Nixon party, Nixon's party's politics, Nixon's party's foreign affairs, Nixon party's pacifist understanding, which is the length is longer. But when you look at here, Nixon's opinions on foreign affairs, and Nixon's pacifism understanding, which is shorter. And we have already spent 40 minutes. Maybe I can explain the attribute types a little later. But I will give you one article. You can check it. It is the actually last article that it's the last article that Wieslawski actually has written. It is identifying subjective attributes of the entities. If you understand this concept, you can again write better articles for product review update related algorithms as well, and also you can write better definitions too. You can also check the patent if you want. Here, identifying subjective attributes by analysis of curation signals. When you look at the curation signals, it is actually what we call as listicles or product lists or something like that. I will give you one more, content item selection criteria, which is a latest thing from Google. And I believe it has been, the days here are not updated actually. It is also, it's not abandoned. No, it's not. Mine is not about generation. Sorry. Let me go to the Justia. Maybe I can find it. One of them is here actually a little, but there are more things here that I can actually mention. When you look at the content item selection or content item selection criteria, they actually, every content item means that we have a web document, and any text or text span or image span or combination of these multiple things, they actually represent different types of content items, and we try to select them for different types of things. Actually, just a couple of days ago, the search engine actually published a new update again, and they were talking about pros and cons in the articles. They even actually added these pros and cons to the, let me just write here, to the structured data as well. And they have done it after they actually performed some tests on the Google SERP. So basically, they actually found a new content item on the pages. And here too, they say that actually, let me just read it. Product review often contain a list of pros and cons. So basically, this is a content item and they have selected it and then they have performed a test for it. Then they have also liked the results and they have added it into their own search gallery under the product review update plus product structured data. So to be able to understand the next attribute related things, you will actually need to read these subjective attributes a little further. Then I can actually answer more questions from you, because to be able to ask the most related questions to me, you will actually use this type of language so that you can actually use these things. And here too, we talk about selections like likes, comments on a website, or bookmarking, or adding these things, and etc. Color, texture, intensity, meta tags, and also some other things, even scores or media clips, blog entries. Anything here actually can be used for extracting attributes plus actually for content item selection, and they are connected to each other. Okay, if I stop here, do you have any further questions for me? I hope you have. It would be more helpful for you. Edwinas, any question?
Can't think of anything right now. Need to process everything.
Okay, most probably we will have 3 more lectures, I guess. I am just guessing. We can do the second one or the second one even tomorrow if you want. Do you have time, or will you be able to have time?
Yeah, time for this session is actually scheduled already, so yeah, tomorrow.
Okay, so basically I will explain the attributes and then attribute parameters. Then I will also explain the subjective attributes a little further. Then we will dive into the frames, and after the frames, we will actually understand knowledge representation a little further, or also factual search engine understanding. And then we can actually end these lectures. Okay?
Okay.
Okay, then next time I will be opening my camera, I promise that. And thank you for listening to me. See you tomorrow.
Thanks.
Thank
Bye.
you.
Thank
Thank
you.
you.
Thank you. Bye.